Here we have the integral dx over the square root of x squared minus a squared, and the first thing I'll do is I'll rewrite this to make it something more recognizable as the integral of 1 over the square root of x squared minus a squared dx. And now that we have it in this kind of standard form, we can recognize the indication of a trig sub. We have x squared and a squared, and because we have a subtraction symbol there, that indicates that we're working with a secant or a sine trig sub. And in this case, because a is after x squared comes first, we know that we're working with a secant trig sub. And so what we can do is we can say x equals a secant theta. In this case, the derivative of x equals a secant theta tangent theta d theta. And so now we can take these values and we can plug them back in to our original integral. And so we can rewrite this as the integral of a secant theta tangent theta over the square root of a squared secant squared theta minus a squared. And then we can put d theta at the end there. Now we need to recognize that a just represents a constant, and we can perform a constant purge where we move our constants out to the front. And so simplifying, what we have is a over, here we have a squared under a radical, so we can pull that out front as a squared square rooted, which is simply a, times the integral of secant theta tangent theta over the square root of secant squared theta minus 1 d theta. And of course secant squared theta minus 1 comes from the identity that says tangent squared theta plus 1 equals secant squared theta. And so that means this is simply just tangent squared theta, but it's under a square root, which simplifies it down to just tangent theta. And so rewriting all of this, we have the integral, after these cancel, of secant theta tangent theta over tangent theta d theta. And of course here the tangents will cancel, leaving us with just the integral of secant theta d theta. And this is an integral that many professors will have you memorize because otherwise you will have a very tough time figuring it out. It's actually a famous integral because of that. And so using our memorization skills, we know that the integral of secant theta is simply the natural logarithm of the absolute value of secant theta plus tangent theta. And because this is an indefinite integral, we have no limits here, we know that we must add a constant at the end. And now that we're in this form, all we have to do is recognize that we're still in terms of theta here, and we started this in terms of x. And so we need to resubstitute, stemming from right here, our x value back in. So if we rewrite down here that x equals a secant theta, then we can deduce that secant theta equals x over a, and now we can use this to draw a triangle. And if we use this as theta, secant is hypotenuse over adjacent, so we'll have x here and a there. And then we'll put a standing y there for now. And we can say that x squared equals y squared plus a squared. Solving now for y, we can get y equals x squared minus a squared under a radical. And so that will go here, x squared minus a squared. And so tangent theta, in this case, equals opposite over adjacent, which is the square root of x squared minus a squared over a. And so finally, what we can do here is we can plug these values back in. We can say the natural logarithm of the absolute value of x over a, and then we can add the square root of x squared minus a squared over a, adding that constant at the end. And this is technically the result of our integral. Now, you may see this in other forms elsewhere. One other form that you may see is if you combine the denominators here, you say the natural logarithm of the absolute value of x plus the square root of x squared minus a squared all over a plus c. Now, what you've got is a quotient in the natural logarithm. And what that means is that you can subtract them. So you can say the natural log of x plus the square root of x squared minus a squared minus the natural log of the absolute value of a plus c. And in this case, of course, a is just a constant. And what that means is that the natural logarithm of a is also just a constant. And so because this can be rewritten as a constant, now we have a constant plus a constant, which is just a constant. And so what this can also be simplified down to is the natural log of the absolute value of x plus the square root of x squared minus a squared plus a constant. And this is a decent alternative version of our answer to our integral. If you have any questions, leave them in the comments below. Otherwise, I hope that you found this helpful.